want to cover a topic or a subtopic that involves, that is, molar solutions. I want to start by talking about concentration. Concentration. When it comes now, concentration in solutions that we are using in our labs. Now, concentration. Now, I want to start by saying that you know about concentration when it comes to a solution. Let me just give an example with either salt solution, or sugar, and this will be, I'm just giving an example of this so that we can understand from here. Now, when you dissolve a salt, let's say this is a container, a 200 container. When we have a certain amount of sugar in this container, we have another bigger container here that is around 500 ml. Now, for example, let's say here you dissolve 20 grams and here still have 20 grams. Now, and maybe, let me just say, when you test the two solutions, this one will be, well, the tests here will be concentrated than in this solution, where we have our solvent 500 ml. Now, so when we dissolve our solid in a solvent, we get a certain concentration depending on the amount of solid and still depending on the amount of solvent that we have. Because if I use a different grams here, I can assume a certain amount here so that we will have the same test. But remember, now I will have to add more solid because of the volume is 500. Now, when you test the two, you will realize that this one is more concentrated. Now, when it comes to concentration in chemistry, I want to talk about, for example, when you dissolve 4.0 grams of sodium hydroxide. Now, when you dissolve 4.0 grams of sodium hydroxide, let's say in 200 centimeter cubed solution, then you add water maybe up to 250 centimeter cube. So if I ask you what is the concentration of sodium hydroxide, for this case you are going to tell me that this is 4.0 grams per 250 centimeter cube solution. Now this is the concentration. That's where we are going to say that this mass is dissolved in 250. Now, I want to give this in terms of moles. This is 4 grams that are dissolved in 250 ml solution. Now, if I want to give this in terms of moles, I'm going to say that I know the molar mass of sodium hydroxide. The molar mass of sodium hydroxide is equal to 40 grams. And the molar mass, we say this is mass that is equivalent to 1 mole. Now, we are going to say that 1 mole is equal to 40 grams. Now, what about 4.0 grams will be equal to how many? So, it will be 4 divided by 40. So, what are we going to get here? 0.1 moles. So, if I want to give concentration in terms of mole, then I will say the concentration is 0.1 moles per 250 centimeter cubed. We are going to move to the next thing, that is giving now in terms of or giving this concentration in terms per liter solution. And that's where molarity comes in. Molarity in any case is going to be per 1,000 centimeter cubed, which is equivalent to 1 liter. We normally say that 1 liter is equal to 1,000 centimeter cubed is equal to 1 decimeter cubed. What we are going to do here, we have this one, 0.1 moles per 250. And then we want to give molarity. Now molarity, now we were going to ask ourselves, what about in 1,000 centimeter cubed? And here we are going to cross multiply. So you get 0.1 times 1,000 divided by 250. Now here we're going to get, we have that, and we have 4. So we're going to get 0.4 moles per 1,000. This is what we call molar solution. 0.4 m, which is representing molarity. So how we prepare preparation of molar solutions. We ever have said molar solution where we are talking of our moles, that is molarity, moles per liter, molar solutions. Now, for example, if we are working on this sodium peroxide, maybe 4.0 grams, we dissolve this one in 400 centimeter cube. Then after that, we add up water to make 1 liter. 1 liter, which is 1,000 centimeter cube. So we want to determine the molarity for this solution. So we are going to say that 4.0 grams were dissolved, that is 4.0 grams were dissolved in 1,000 centimeter cube. So this can be our concentration now that we have. But then we know the molar mass is 40 grams. This is equivalent to 1 mole, the molar mass for sodium hydroxide. So what about 4 grams? It will be equal to 4 times 1 divided by 40, which is equivalent to 0.1 moles. So our concentration here will be 0.1 moles per liter, which is M.